Hello everyone. Today we shall discuss, this is my fifth lecture, and today we shall discuss about the some numericals related to Coulomb force. There are few numericals which I have selected. Some of these are from NCERT book and some of these are other books. The first question is a very simple question. What is the force between two small charge spheres having charges 2 into 10 raised to power minus 7 coulomb and 3 into 10 raised to power minus 7 coulomb placed 30 centimeter apart in air? This is the simplest form, and for the answer of question number 1 is the values are given to us. Q1 is equal to 2 into 10 raised to the power minus 7 coulomb. Q2 is equal to 3 into 10 raised to the power minus 7 coulomb. And for air and vacuum, the values are equal, and it will be 9 into 10 raised to the power 9 Newton into meter square upon coulombs. And the separation of charges is R is equal to 30 centimeter, and we shall convert it into meters. So 30 into 10 raised to the power minus 2 meter. The formula is F is equal to K Q1 Q2 upon R square, and for vacuum it is 0 and it is 0. Now we shall put the values. 9 into 10 raised to the power 9 into 2 into 10 raised to the power minus 7 into 3 into 10 raised to the power minus 7 upon R square means 30 into 10 raised to the power minus 2 into 30 into 10 raised to the power minus 2. And this is the value 10, and this is 10, and this is 3 to just 6 into 10 raised to the power. On solving the powers, 9 and 2 11 and 2 13 and 7 and 7 14, then 15 and 16. 16 minus the powers are 9 minus 7 minus 7 minus 2 plus 2 and plus 2. 7 and 7 14 and 2 16, 9 and 2 11 and 13. So it will be 6 into 10 raised to the power minus 3, 6 into 10 raised to the power 9 and 2 11 and 2 13, 7 and 7 14, or minus 2 16, so minus 3 meter. So 6 into 10 raised to the power minus 3 Newton. This is the value and solution of the question number 1. And Q1 is equal to, again I am repeating, Q1 is equal to 2 into 10 raised to the power minus 7 coulomb. Q2 is equal to 3 into 10 raised to the power minus 7 coulomb, are placed at 30 centimeter apart, and we can convert it into meters. So 30 into 10 raised to the power minus 2 meter. The value of K for the air and vacuum, we consider the sum values. 9 into 10 raised to the power 9 Newton into meter square upon coulomb square. So F0 is equal to K0 Q1 Q2 upon R square. And on solving this, we can calculate the value of 6 into 10 raised to the power minus 3 Newton. Now we go through the question number 2. This is the solution. Now we go to the question number 2. The solution of question number 2 is 4-point charges. Qa is equal to 2 microcoulomb, Qb is equal to minus 5 microcoulomb, Qc is equal to 2 microcoulomb, Qd is equal to minus 5 microcoulomb, are located at the corners of a square A, B, C, D of side 10 centimeter. what is the force on charge of 1 microcoulomb placed at the center of the square. So we draw a square for the solution, and this is the square. And each side of the square is 10 centimeter. This is 10 centimeter, 10 centimeter, 10 centimeter, 10 centimeter. This is corner A, and charge corresponding to this corner QA is equal to 2 microcoulomb. This is corner B, QB is equal to minus 5 microcoulomb. This is corner C, QC is equal to 2 microcoulomb, and this is corner D, QD is equal to minus 5 into minus 5 microcoulomb. On joining the AC and BD, we obtain the center. What is the force on charge 1 microcoulomb placed at the center of the square? This is the center of the square O, and the magnitude of charge is 1 microcoulomb. First of all, we calculate the OA, OB, OC, OD values. OA is equal to OB is equal to OC is equal to OD for a square, and it will be BD by 2 or AC by 2. BD or AC by 2. For the value of BD, under root 10 square plus 10 square from Pythagoras theorem, and it will be is equal to 10 under root 2 centimeter, and OA is equal to BD by 2, means 10 under root 2 by 2 is equal to 5 root 2 centimeter, or 5 root 2 into 10 raised to the power minus 2 meter. This is the value of OA, OB, OC, OD, and we can consider it R. Now, we know that this is a positive charge, and this is also a positive charge, so force exerted by QA will be along this side, FA. And this charge also repels this charge, and the direction of FC means force exerted by the charge QC 2 microcoulomb on 1 microcoulomb will be along this direction. Both forces FA and FC are equal in magnitude and opposite in direction, and that will be K Q 0 QA by 2 is equal to K Q0 QC by 2. Both forces are equal in magnitude and opposite in direction, so FA is equal to FC. FA plus FC is equal to 0. Similarly, for FB is equal to FD, because here is the attractive force FB towards the B and FD is towards the D point. Both forces are equal in magnitude and opposite in direction, so they also cancel out, and there will be the value of K Q0 QB upon R. Here also we can write R, and this is K Q0 QD upon R, and FB plus FD is equal to 0. So total charge at point A is FO is equal to FA plus FB plus FC plus FD is equal to 0. This question is based on the superposition principle, and in this manner the total charge on 1 microcoulomb, which is situated at the center of the square, is 0. So this is the question number 2 and the answer is this. And now we shall discuss the question number 3. Consider the charges. Again I am repeating, A, B, C, D are the 4 corners or vertices of a square and their charges are 2 microcoulomb, minus 5 microcoulomb, 2 microcoulomb and minus 5 microcoulomb, and at the center of 1 microcoulomb charge is placed, and the total charge on total coulomb force on this charge is 0 because Fa and Fc are equal in magnitude, opposite in direction, so they cancel out, and Fb and Fd are also equal in magnitude and opposite in direction, so they also cancel out, and in this manner the total force on the charge at O point, that is 1 microcoulomb, will be is equal to 0. Now we shall discuss about the question number 3. Consider the charges Q, Q and minus Q placed at the vertices of an equilateral triangle. What is the force on each charge? So for the answer of question number 3, we draw a triangle. It is also based on superposition principle of Coulomb force. This is vertex A and this is minus Q charge, and this is vertex B, this is plus Q charge, and this is vertex C, this is also plus Q charge. And we can consider this distance is just like x, x and x. Let the forces due to on the vertices of charges, each charges, and the triangle, what is the force on each charge? Means we have to calculate the Coulomb force at point A due to these 2 charges, at point B plus Q charge due to these 2 charges minus Q and plus Q, and we have to calculate the points at point C on plus Q charge due to minus Q and plus Q charge. First of all, we consider the point A. At point A, this negative charge is attracted by the discharge and this negative charge is attracted by this charge. So the value of F, A, B and F, A, C are along this direction. And then the resultant for this will be along by the parallelogram law of vector addition. In this manner, we can calculate the value of resultant force A at point A will be the result vector sum of FAB and FAC. The value of FAB is equal to K Q Q upon x square. Means KQ square upon x square. And similarly, FAC will also be equal KQQ upon x square, means KQ square upon x square, means both forces are FAB is equal to FAC is equal to F, and its value is KQ square upon x square. Now we calculate the resultant force. This angle is no doubt about that because this is equilateral triangle, so angle is 60 degree, and F is equal to the vector sum of these 2 forces will be is equal to F square plus 2 F1 F2 cos 60. And in this manner, the value will be is equal to F square plus 2 F square F1 and F2, the values are same, and cos 60, the value of cos 60 is 1 by 2, 2 and 2 cancel out, so force at point A will be is equal to under root 3F. or under root 3 into kq square upon x square. This is the net force at point A. Now we shall discuss about the at point B. At this point, the direction of force C will be F. B, C is along this direction because it repels and this charge attracts. So the direction of this force will be is equal to F. A, B is along this direction. And the resultant can be calculated by the parallelogram law, and this is along this direction, and the angle between these two, because this angle is 60, so this angle will be 120 angle, and FAB and FBC, FAB and FBC are equal. Similarly, KQ square upon x square, and resultant at point B will be is equal to under root f square plus f square. We can consider it also f plus 2f into cos 120. And value of cos 120 is minus half. 2 and 2 cancelled out. So in this manner, f square plus f square plus 2f square, and value of cos 120 will be minus half. 2 and 2 cancelled out. So the resultant will be equal to f. B at point B, FB is equal to KQ square upon x square. Similarly, for the point C, this force repels this in this direction, and its value is again FBC, and this value is FAC. Similarly, from parallelogram law of vector addition, the direction of resultant force FC will be is along this direction, and the angle is no doubt about that. This is 60 degree, then this angle will be 120 degree, and similarly, FAB is equal to FAC is equal to FBC is equal to F is equal to KQ square upon x square, and at FC similar by the addition of above formula, the value will be same. FC is equal to F, and that will be equal to KQ square upon x square. So in this manner we can calculate the question number 3rd, and by adding the vector addition we can calculate the solve the question by vector addition with the formula, and we can calculate the values. This is the question number 4. Now we shall discuss about the question number 3rd. Now we shall discuss about the question number 4. This is also based on the superposition principle on Coulomb force, and this will be is equal to this one. The solution for the question number 4 will be this. Two identical charges Q, each are kept at a distance r from each. Two charges are separated by distance. This is the Q and this is also Q. We can consider here the point A, this is point B, and the separation of the charges is r. A third charge Q is placed on the line joining the above two charges such that all the three charges are in equilibrium. What is the magnitude, sign and position of the charge? We can consider that there is a charge at point O, and this is a small q charge, and the separation from the point A is x. So from this point, this distance is r minus x. Now we shall calculate the position of this charge q and its magnitude and its sign. The first of all, we consider in order to determine the position, we can find the force on this charge due to these charges, and that force must be equal to 0. So the first is Q upon x square is equal to, this force should be equal to this force. So k q upon x square is equal to k q upon r minus x square. Both forces must be along opposite direction so that this charge can be equal, and k q can be cancelled out. So r minus x square is equal to x square. Taking square root, r minus x is equal to x. So r is equal to 2x and x is equal to r. The position of the charge q will be at the midpoint of the line joining the two charges. This is the first position, and in order to determine the magnitude of this charge, we shall consider this charge, and we can calculate the discharge and discharge and discharge and discharge, and we can put the value of r, and then we can calculate the value of q also at this point. For the determining the magnitude of charge, we consider a sided charge, and for determining the position, we consider the equilibrium at middle point. So here is the k first force due to at point this point. The first force due to a k q upon r square is equal to force on this charge due to this charge k q upon r by 2 square. Both forces must be equal. So this is the k q upon r square. This is k q upon r by 2 whole square. Kq and kq cancel out. So q is equal to q into r square upon r square by 2. R square and r square cancel out, so q is equal to 4q and q is equal to q by 4. So this is the magnitude of q is equal to q by 4, and the position is x is equal to r by 2, and sign will be opposite to these two charges. So the sign will be, if these two charges are positive charges, then the magnitude sign of small charge q will be negative sign. So this is the position, this is the magnitude of charge, and this is the sign of the charge. So in this manner we can calculate the questions and we can solve the questions. And now I am going to give you the homework and then you solve it, and if you have any kind of problem, you can contact me. My number, that is 8386092786. Thank you.